Okay, here we go. We're going to wrap up section 6.3 with a new type of distribution, and that's the geometric distribution. Now, the geometric is different. It has some things that are similar. Okay, we still have to be binary. We still have to be independent. The success rate is still, the same. However, with a geometric distribution, you're looking to find the first time something happens, okay? So, in a binomial setting, the number of trials is fixed. They tell you ahead of time, n equals something, okay? Here, we're trying to do it until we find the first success, okay? Roll a pair of die until you get doubles. Attempt a three-point shot until you make one. Place a 1 on 15 in roulette until you win. Okay, so you're looking for the first success. When they ask you for the first success, it has to be a geometric distribution. Okay? Geometric settings. The trials are independent and the probability is the same. So a lot of it's the same. Okay, the difference is instead of using bins, we are going to use bits. Bins and bits. Okay, kibbles and bits. So here's the explanation of bits. Here are your four conditions. Binary, the same. Success or failure, okay? Two things that can happen. Independent, knowing the result of one doesn't affect the other, the same. Trials, count the number of trials until you get success. That's what makes it geometric, okay? Success. On each trial, the probability must be the same. Okay? So, it says in a geometric setting, if we define the random variable y to be the number of trials needed to get the first success, then y is geometric random variable. The probability of y is a geometric distribution with parameter p, probability of success on any trial. Possible values of y are 1, 2, 3, and so on. We don't know when the first one's going to happen. Okay? Here's your formula. Okay? Probability y equals k, the first time, your first success. 1 minus your probability to the number minus 1 times p. Okay? And they have to give you that number. That's what they're going to give you. They say, what's the probability that they make their free throw on the fourth shot? So then 4 is k for this formula. Okay? It's kind of a neat thing, this little birthday game. We really can't do it, but there's this crazy thing in statistics that says, this isn't it necessarily, this isn't the one I was thinking of, but there's if you Google probability of having the same birthday, there's this statistical formula that tells you have to have a room full of, like, I don't know how many people, I don't want to say it and say it incorrectly, but it's a lot less than you would think. Fill a room with X amount of people and the probability that 2 people have the same birthday. Okay? Look it up. I don't know what it is. But I found it interesting when I found that. This is different. This birthday game is different. But we're not going to do it because we're not here. Okay? We're not live, so I can't do that one. All right. Next, let's look at a situation. Monopoly. Everybody loves to play Monopoly, right? I used to love to play Monopoly. It's a long game. You got to be patient. Okay? You can't have someone like Soltis who can't sit still probably doesn't like playing Monopoly a lot. Okay, you can't sit still for that long. So the random variable interest here, y, is the number of attempts it takes to roll doubles one time. Each attempt is one trial of the chance process. They're checking your conditions. They go through the conditions here. Binary, independent, trials, success. It fits. Okay? Either you roll doubles or you don't. You're successful or you don't. Binary, taken care of. Independent. One roll of the dice is independent from the next, or the one before that. Trials, you're looking until you get doubles one time. Okay? Number of attempts it takes to roll doubles one time. So that means it's geometric. And success, the probability of getting doubles is 1/6 each time. So, find the probability it takes 3 turns to roll doubles. So, I'm going to show you how to do this out. I think doing the geometric one, doing it out, without the formula is the easiest way to do it. Okay, but I will show you doing it out, I will show you the formula, and I will show you the calculator, and you can pick which way is easiest. Okay? So, probability of rolling doubles. Probability doubles in 3 rolls. So, x equals 3, right? So what happens? What happens the first 2 times that you roll doubles? If you're successful on the 3rd try, here's the first situation, here's the second situation, here's the third. This is when you're successful. That's 1 in 6. What happens the first 2 times? If you're getting doubles for the first time on your 3rd roll, what happens on your first 2 rolls? You failed. 5 out of 6, 5 out of 6. So it's 5 out of 6 squared times 1 out of 6. We're going to remember that. I'm going to bring you back to this. I'm going to bring you back to this, okay? And so let's do the math. Let's do the math. Let me see. I think I got 0.116 for that. 0.116. Okay? All right. Now, find the probability that it takes more than 3 turns to roll doubles and interpret the value in context. So, more than 3. So, the probability that x, think about how are we going to write it? How are you going to write more than 3? How do you write more than 3? Okay, think of your inequalities. Taking you back to algebra. Okay, you guys thought this stuff was gone forever. More than 3. X is greater than 3. So if you're picturing all these things, right? And we don't know, we can't stop here. We can talk 1 and 2, 3, 4, 5, 6. How many turns it takes for you to roll doubles, okay? How many turns it takes. Could be the first try, could be the second try, third try, fourth try, fifth try, sixth try. We don't know where the end is. Okay, we don't have a fixed number of trials. The probability that x is greater than 3. So that would be, we want to find this. Okay, and don't forget it continues. Okay? All of these probabilities, just like with binomial, has to add to 1. So we could do 1 minus the probability that x is less than or equal to 3. Okay? So what does that mean, the probability that x is less than or equal to 3? Well, that means that it could be x equals 3. It could be that x equals 2. Or it could be that x equals 1. Any of those will work. Okay? So let's think. And I'm just doing this right now, okay? We're going to worry about the 1 minus after. That's what we're doing here, okay? So the probability that x is 3, you get your first roll on 3. I think we did that up here, right? So you failed, you succeeded. So that's 5/6 squared times 1/6, and the answer to that was 0.116. Now, the probability that you get it on the second roll, that means your first roll you failed. And the second roll, you got it. So that's going to be what? 5 out of 36? I don't know if I have that done. Let me look. Yeah, I don't. So 5 div 36.139. And then the probability that you get out of your first roll, well, that's a 1 out of 6, right? And 1 divided by 6 equals 0.167. So for this, it says 1 minus the probability of these, so we get to add these together, okay? So I take my 0.167 and I add it to 0.139 and I add it to 0.116 and I get 0.422. So 1 minus 0.422 equals 1 minus 0.422 equals 0.578. Okay? Hopefully that makes sense. Okay? Hopefully that makes sense. Now, there's an alternate solution to that. There is an alternate solution, and I want to show it to you. Okay? You could do it this way. This way makes the most sense to me. In my head, I can do this. In my head, it makes sense. Okay? Now, there's an alternate solution where you say P of X is greater than 3. That probability is the failure rate cubed. And watch what happens. This is going to be 125 divided by 216. Let's watch what happens here. 125 divided by 216. 0.579. It's actually 579. I don't think I didn't round necessarily right there. Same, okay? Same. So you could, if they say this, greater than 3, then you take the probability of a failure and take it to whatever power. So if they said, what's the probability that it takes more than 4 rolls, then you would do 5, 6, which is the probability of a failure, to the 4th. You could do it that way, or you could do it the way, now the way I did it is a lot longer, but in my mind that makes more sense. Okay, but if you want to memorize this formula, that when it says more than, you can do it that way. Okay, if I said more than 5, failure is 5/6, put a 5 there. Okay, that's it. That's it. All right, so that's the Monopoly stuff. Another example here, geometric random variable. Okay, let me see if I must have a formula somewhere. Let me look and see where the formula is before we continue. Where is the formula in my notes? Oh, it's way down here. I don't know why. Yeah. So here's the formula. I don't know why it's here. Maybe it's a little out of order. You can find the formula. You can find the answer to these, okay, by taking 1 divided by your probability. Okay, so if you're finding expected value, which is also a way of saying the mean, it's 1 divided by the probability. So for this one, it says 22% of all vehicles in use in the United States are Fords. When randomly choosing vehicles in use, how many vehicles do you expect to choose before you get a Ford? So you're doing an expected value here, finding the mean, okay? It's 1 divided by your probability, so this would be 1 divided by 0.22. So you go type that in, 1 divided by 0.22, 1 divided by 0.22, and we get 4.55. And there's your expected value. Expected value, whatever the random variable is, didn't say here, I'll say expected value. All right? That's how you do it. That's how you do it. All right? So let's look at some other examples. What is the probability? Try this one. What is the probability you don't choose a Ford until the 6th choice? Until the 10th choice. So this is not, it is not more than or anything. Okay, so I want to see, we're going to do these out. Okay, we're going to do these out, and then we'll go over how to do it with we can do it with the formula. Okay, I'll do both. See what you do. Work your magic. Try them. Try them. Just do the first 2. I can't sit still here, right? I want to get going. Okay, so, again, I'm going to show you how to do this out, all right? I don't know, to me, doing this out is the way to go, okay? So, what's the probability you don't choose a Ford until the sixth choice? So, if the probability you choose a Ford is 0.22, what's the probability you don't choose a Ford? 0.78. So there's my first choice, ready? Sixth choice, 1, 2, 3, 4, 5. Here's my sixth choice, okay? Fail, 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 success. So that takes us to our formula. The formula said the probability to the k minus 1, right? Or 1 minus p, right? 1 minus p to the k minus 1 times p. Well, that's what we did. That's what we did, all right? That takes us to the formula on the sheet. I don't know where it is. Right here, okay? Right here. Same formula. We're doing it right here. We did it out. We need the formula. Okay, we don't, when you can do it out, you don't need the formula, it's even better. Okay, but to show you that it works with the formula, 0.78, what do we say? The sixth shot to the fifth. 1, 2, 3, 4, 5. Yeah, that's what you do. Times 0.22. So when you do that, I'm going to cheat and give you right to the answer here. So that would be 0.0635. Hopefully you got that. Hopefully you got that. 0.0635. Okay, hopefully you got that. Now, the 10th choice, I could do this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where this is my success, and the rest are all 0.78s. So I've got 0.78 to the 9th times 0.22. The probability that I see the first Ford, okay, on the 10th choice is 0.02, only a 2% chance. Okay, very small probability. Small probability. Okay? Try the next one. And then we'll think about the one after that. Try the next one. Okay, so she makes 15% of her free throws. What's the probability the first one is the 7th shot? 1, 2, 3, 4, 5, 6, 7. She made it. 15%. Boy, not a good free throw shooter. I think this was a shot. This was a shot. I think I had Michelle Zawalski in my class at the time. It was like a shot. Shots fired. Okay, so 0.15 is the 7th shot, so that means all of these were failures. So you could do 0.85 to the 6th times 0.15 if you use the formula. Okay? And let me look. I got 0.0566. 0.0566. Okay? I'm going to check my math here. Check my math and show you something pretty fancy. What did I say? 7th shot?